Hey, hello guys. Hope you guys are doing extremely good. Let's start today's Geeks for Geeks daily challenge. Okay, it was June 23rd. Okay, I think the Wi-Fi was too slow. Okay. The actual question is number of zigzag arrays. Okay, which is a one. Okay, you are given a three integers n, l, and r. Okay, the zigzag array of length n is defined as each element lies in range only in between the l and r. Okay, no two adjacent elements are equal. No three consecutive elements form strictly increasing or strictly decreasing sequence. Okay, there are three conditions, right? Okay. Return total number of zigzag arrays. Okay, the answer might be large. Return the modulo of okay 10 for okay mod. The sequence is said to be strictly increasing. Okay. Sequence is strictly decreasing. Okay. Let's take this example 313. Okay, so all the elements should be in this range and then no two adjacent elements are equal. No three consecutive elements form strictly increasing. Okay, all the elements are in the range of 1 and 3. Okay, no two adjacent elements are equal. Okay, and then okay, we don't strictly increase. I think this third this third requirement was much makes sense, because if there is a no three consecutive elements of no strictly increasing, what does mean is we can have 1 and 2, but we don't want 3. So that is the exact rule. So if we don't include 3, right, so let's say we can also include 5 as well, because like they don't want to be consecutive elements. So consecutive element in the sense we can have the consecutive the element next to each other, but those elements are not those are not needs to be consecutive. That's a two different points. Like, so three consecutive elements. So consecutive element, they doesn't want to form strictly increasing. Consecutive element is the sense of those elements are the next to each other. Okay, but though I think consecutive means like they are not mentioning about consecutive elements. So which I was trying to say is 1, 2, and 3. These three are consecutive elements, right? Let's say 4, 5, and 6. These are consecutive elements. Okay, so have so if we don't have any three consecutive elements, then we can't form any of strictly increasing or strictly decreasing as well as in future, because 6 was not possible, because if the length 3 itself not possible, so we don't end up with forming the length 4, right? So this this point was much makes sense. And then okay, it's big value. And then the constraint was like, okay, all the elements rise only in between 2000 2 times of 10 power 3. So then okay, do we have at least 3 numbers? That was fine. So n would be less than or equal to, we can say 10 power 3. Okay, so the quiet approach I was seeing, like it's definitely a DP one. So here we can just keep track of what the previous element that we have taken, and then so if we need to know what the previous element that we have already taken, so that will handle the second condition. So to handle the third condition, I know three consecutive elements, which means that let's say we have 5 over here and then 6 over here, and then we need to know what the element. So we need to know the n. We need to choose it over here, right? So here the number which are all greater than 6 is not allowed. Let's say if it is 9 over here, the number which is greater than 9, which is not allowed. So if we keep 9 over here, then the second condition will fail. But if we keep 10 over here, the third condition will fail, right? So whatever number, if we 19 over here, the third condition will fail. So we also need to keep track of the previous to previous. So let's say like we need to get previous to previous. So and then we need to know what the index that we are currently in. So the states are, so these are the states, right? So we need to know what the element that we have, what the index that we are in. I'll just make the index. So like, so this would be end up in like the index would reach 2000. So 2000 and then the previous number, like that can be anything in the range of 2000 and then the same, and then the previous to previous 2000 and then the same, the previous number might also be 2000, like. So here we could have the overall time complexity would be 2 3 times of 2, which is 8, and then 8 times of 3 so 10 power 9, so 8 times of 10 power 9, so which is not hardly possible, right? So actually I was thinking that, so we so we need to reduce the state. So this index we can't do anything because we must need to know like so far how much number we have processed, and then this previous to previous, I think we can do something over here, and then the previous element also we must needed it. So because if we don't know what the previous element, like none of the condition that could be satisfied, like. So instead of having this we can have something like, um so we can keep track. Actually I was thinking like here the 5 was chosen, right? So if we are going to choose 9 or the number which is greater than 5, let's say if we are going to choose 7 over here, we can just pass the previous to previous, be like this is ascending, like this is ascending. We can just make this previous to previous as ascending, and then the same, like if it is, if the previous to previous was 5, and then the current number which I was going to choose was 3, we can just say like, hey, the previous to previous guy, you are PC END. I think I don't know the type of, okay. We can have something, we can just keep track of something like this, like, hey, if it is ascending, like, oh, okay, hey, this is ascending, so don't choose a number which is, skip all the numbers which is greater than 7. Hey, this is descending, like skip all the numbers which is less than 3, because here we can choose the numbers in the range. The possible numbers would be, we can choose only from 1 to n, right? So 1 to 6, like the same over here we can just choose the numbers which should be the greater than of 3, because this is already be descending, like if we choose 2 over here, the third condition will fail. So the possible numbers should be 4. We can't choose here 3 to 3 to, we can say right side, we can choose right. So like this is wrong, left. So we can't say, hey, I can choose 3 to right, because if I choose 3 over here, the second condition will fail. So it should be 4 to right. So I can choose all the numbers which rise in between 4 to 7, and then in this case I can choose all the numbers which lies between the left to 6, right? Okay, I think this is the intuition for this. Like we can just start coding, like. So they mentioned like the answer might be large, we need to the mod. Lord, I love this part, like mod. Okay, 10 power 9. Very bad. 2, 3, 4, 6, 7, 8, 9. Okay. And then like as we mentioned like private, so we can just keep it as long, so it will help to not the integer overflow. Like we can just go with the index, and then so how to yeah, we can just pass it again, and then what we need. So we need previous to, okay, sorry, we need this ascending, like, so now the states will become like, we can keep track of index, and then we need a previous, and then we need to know whether the previous whether the previous, what to say, like whether the previous sequence were an ascending or descending, right? So we can do is ascending or is descending, we can see we can simply say like we can keep track of integer like so the if it is 0 means neutral, and then if it is 1 means ascending, and then if it is 2 means descending. Okay, so we can just keep track of delta. You can say something like delta. This would define, this will tell us that okay what the previous state, and then okay this is the state, so this would becomes like 2000 times of 2000, like yeah, because index will range to 2000, and then to the previous one will become 2000, and then the delta here we have 0 1 2 so 3, so now the time complexity would be big O of like 2 times of 4, and then 4 times of 3 was 12, right? 12 times of 10 power 6, 10 power 6. I feel still this is heavy. I would say this as 1.2 times of 10 power 7. So okay, this will become, eventually this will become, wait, I need to calculate this separately. This is not in the expected range, it seems like. So this would become 1.2 times of 10 power 1.2 times of 10 power 6, which eventually which it would become like 1.2 times of 10 power 7, and then we can simply say this 1.2 is constant, like 10 power 7, like 10 power 7. We can simply say this as 10 power 7. Wait, actually what the actual value is, 1.2 times of 1 2 3 4 5 6 7. Okay, this was fine I think, but seems with LeetCode usually it will give if it is exceeding beyond 10 power 8, right? So if it exceeds beyond 10 power 8, it will give the time limit exceeder. I was thinking it was good, but it's not very good approach, because like it was lying in between. It was lying the edge, like we can't say it's a good one. Okay, we can just give a try. That's it. Okay, the previous number, and then we need int delta, and then what else we need, and then we need the range, right? Okay, can simply say the base condition if n is equal to 0. Hey guys, simply return 1, or else long base should be 0. You can just start from num. You can just start from each num. Num equal to L, and then num is less than or equal to right, and then num plus plus. Okay. What if it is starting number? Like we need to check these two conditions. Like okay, the first thing is if num was not, if my current num, and then if my previous was not equal to my current number. Okay, hey, the previous is not equal to current number. We can allow that, like okay, base equal to base of n minus 1, and then previous was num. and then okay, now we need to check if it's delta, right? What we can just go with int current delta would be, initially the current delta would be 0. We can check, hey, if okay, we can check, hey, if my previous was greater than my current num, if it is greater than my current num, I would say go it as 1, else go it as 2. Okay, this is my current delta, and then left and okay, we need to check, okay, we need to check the current delta as well, right? So this was the first check, and then the second check was to be the third condition, right? If what if we had, if we are going to choose for the first index, that means like the first number, for first number we can choose in any range, right? We can so we can say like if my n was 0, okay, okay, I think I will go like this, and then yeah. So if my index was 0, so which means that is the first number I'm just going to pick, right? I'm actually I'm eligible to pick all the numbers in the range if I was going to pick the first index, the first number. So I'll just go with exactly like, so no, here also I need to change. If my index was equal to n, okay, and then index plus 1, and then my previous number was, and then my current delta remains 0, and then the left, right, and then n. Okay, else I'm just coming to this part. You can also have this condition as well, like else if my previous number was not equal to my current num, second condition pass, and then now I need to check the third delta part. Okay, so what the thing like, okay, and then for delta part, let's say this is the condition, like, so if it is increasing, if it is ascending, and if it is strictly increasing, we need to choose L26, right? So L26, okay, makes sense. I think we, if it is, this is the case, let's say here the L was 1, I'm allowed to choose all 6 numbers, right? So I can't, I can do something like start equal to, if my delta was already increasing, if my delta was already increasing, I would just make no, if it is already increasing, then I need to update my right. So if already increasing, I need to choose one different 6 to 7. Okay, if it is already increasing, okay, and if it is already increasing, I will take previous minus 1, else go to log. The same for the start as well, like for start, if my delta was already decreasing, I need to update my start as the previous plus 1, right? So previous plus 1, else start from the given range. Okay, I'll just start, and then 1 was less than or equal to n. So if this is the case, I don't want to check any conditions over here. The current delta, I will just make it simply over here, like, okay, if my previous number was 1, and then I'm choosing number greater than 1. Okay, done this. So we'll take mod of it, and then mod of it, done ZigZag arrays of 0, previous was 0, and then delta also would be 0, and then L or N. We can do some what ZigZag arrays, no suitable method int. Okay. N minus one previous current delta. Okay, to add. Okay. This is okay. What a possible none. Okay. So here we need to explicitly convert to possible int. I think we don't need to take mod over here because for every operation we are taking mod. Eventually in parallel. I don't think. I think this is good. Stack overflow. Really. Okay. X plus 1. Here we are good. I'll also give some additional extra test case like if it is n was 5 and then start range was 2 to 3 to 10. Okay, we are good. We are good, and then we need to memorize this actually. It is a long. No, this is actually 3D right? So if my DP of is my current index and then the previous, if I have already seen this state, I'm just copy of it. Like if I have already seen this state, okay, please return that and then the same. You can just return it here. Okay, we haven't initialized this. Can just pass it as n plus 1 and then n plus 1 and then 3. Oh, still actually, I'm just not confused. What? Index is out of bound. What am I missing? Previous. Hey, how the okay. Wait. So n was matter and then here the range, the number of range should be the r, right? So previous numbers. Okay, we are good. We'll just submit this out. I think definitely it will give the TLE, I think, because expected. Okay. I was not sure like why. Actually, it's passing in the terminal test case. Like, okay, so we can still optimize it. We don't okay, because here we are running a loop again, right? That's why it's getting material. Is there any way? Is there any way to? No, I can choose it, right? I can choose. I can choose all 6 numbers in between over here. So is it even possible to reduce the previous? I was thinking whether it's possible to reduce this previous state. So if it is not the previous state, then I don't know like from where I can start. Actually, I was thinking like if the two numbers has already been chosen, let's say if the two number was already chosen, then I was sure like so my range was definitely based on that my range is going to change like over here. see this was very tricky one. Okay. So I think the only way we to reduce the previous one, but this doesn't make sense. Like, how can you even reduce the previous one still one step? How can you even reduce it? Because without the previous one, you can't define the condition 2 and 3. I think we are still okay. Like, is there any way to reduce this for loop? Mm, is there any way to reduce this for loop? No. I think the only way that you how many numbers it will be? Not 2000. So definitely won't even work for, let's say, for 2000. Actually it was executing in 4 seconds because this range was very less. Right. Okay, still good. Not bad. So now we would get TLE. Yeah. So actually here for each number we are just doing an iteration again in the for loop. Actually very bad. I was thinking, okay, hey, if it is 0 I can do it like with my previous number. You can choose any number, so that's what I was still confused. I can choose any number in range 1 to 6. Can I do without even this one? Or am I missing something? I think I'm definitely missing something. The only thing which I can do is that I can reduce this previous number. Without previous, like, how can I determine whether the sequence? Okay, somehow I could say whether the sequence was ascending or descending by this, but for that I need to know like what is the previous number.